Greetings and welcome. Here we are for another video on real-world problems that involve ratios. And this is kind of a supplemental video to the one that was posted last year, just to kind of update with some new strategies that we discussed in class that might be a little bit more clear and easy to understand. So this year we have two main types of real-world problems. We have comparing three quantities and then before and after. And with either of these types of problems, you're looking at what do you know from the problem, what information do they give you, and then can you piece together the breadcrumbs to figure out what you need to find out. Now, along the way, you might need to do some sort of modeling. You might need to do some equivalent ratios to allow you to compare. And so it's kind of like trying to piece together, if I know this, what could I figure out? If I start here, what's another thing that I could learn? So when we're dealing with comparing three quantities, one of the first things, if you've identified a type of one of the questions as this type, is to look and see what has stayed the same. Because once you know what has stayed the same, if that quantity is, or like who, oops, I'm sorry, that's for before and after, I apologize. Not what has stayed the same, but who is the overlap? Who or what is the overlap or the connector or the link between them? Because often you'll get like A to B is this, B to C is something else, and we know that in here these two, they must be equal because they're both the same person or the same thing. So they must be equal. Once you identify who or what the overlap or the link is, then you can do some equivalent ratios, do some modeling, and then do some sort of calculating. When we're talking about before and after, this is where we look at what has stayed the same. Because if it's something has stayed the same, if it's A to B and then A changes, and now you have a new A to B, we know that these B's must be the same. And that allows us to make some equivalent ratios so we can compare the old A to the new A. So we're going to look at a couple problems. These are from the review, so they should be familiar, but they will allow us to see like how do these questions apply when we solve each of these types of problems. So in this question, the ratio of the number of beads Brittany had to the number of beads Sophia had was 2 to 5. After Sophia bought another 75 beads, the ratio became this. So we see in here, after Sophia bought something else, the ratio became this. So that makes me think that this is going to be a before and after, because we only have two people, but something is happening and our total is changing. And so because our total is changing, we know that this is going to be a before and after. If I could write this morning. Okay. So when we do this, let's outline before and then after. So in the before times, we have Brittany was 2, Sophia was 5. So let's see, Brittany to Sophia was 2 to 5. And then in the after, Brittany to Sophia, Brittany was blue, Brittany was 4, and then new Sophia is 15. So Brittany is now 4 and Sophia is 15. In here, if we think back to the questions up above with before and after, what or who has stayed the same, because Sophia got the beads, Sophia is the one who changed. And so that must mean that Brittany stayed the same. So when we look here at Brittany's values, these 2 units must equal those 4 units. So if we're looking at a bar model for this, Brittany to Sophia, we know those 2, and we need Sophia needs to have 5. We duplicate a couple more. Okay. So when we start out here, we know that in the before time, these 2 right there have to be equal to those 4. And so we need to do some equivalent ratio work. And I know that if I have a 2 to 5 ratio, I can multiply this by 2 and make it a 4 to 10 ratio. And that would just be chopping each of these up in half like this. Boop, bloop, bloop. So we're representing the same relationship, but we're just looking at it broken up in a different way. We have a 4 to 10. And so now when we look at it, it's clear that these Brittany from before, her 2 units are 4 units, and after, those stayed the same. So that's great. Now we can compare them evenly, and we can see how much did Sophia's actually change. So Sophia, she went from 10 units to 15 units. So we need to add 5 more units on there. So there's 2, 4, 5. So those are the change, because from 10 to 15 is plus 5 units. And we know that these 5 units in our problem were 75 beads. So those right there are the 75 beads that she bought. So this so far is basically just organizing the information, and we haven't even gotten to solving our question of how many beads did each girl have at first. Well, in order to figure out how many beads each girl had at first, we need to see what is the value of each one of those little boxes. And we have that information that we can find right here. So if we know 5 units is 75 beads, we can figure out that 1 unit is going to be 75 divided by 5. And in my head, I'm thinking this 75 is a 50 and a 25, because 50 divided by 5 is 10, 25 divided by 5 is 5, so our answer is 15. So each one of these little units here is 15 beads. And then we can use this ratio to figure it out. So at first, Brittany had 4 times 15, and 4 times 10 is 40, 4 times 5 is 20. So Brittany had 60 beads at first. And at first, Sophia had 10 units, so 10 times 15 is 150. So here we're able to calculate their values, and it was just a lot of little breadcrumbs along the way. We started out and we took what information do we know, what of these things stayed the same or is the overlap. So we knew Brittany had to be equal, which allowed us to do some equivalent ratios and figure this 4 to 10 out. Once we had that, we could draw our bar model and update it, incorporate our new information, the change that happened, and then do some calculations to get our final answer. So it's a lot of little steps, but hopefully as you start through the process, you begin to see how they're connected. So looking at question 26, some students were playing dreidel at break. When the whistle blew, the ratio of Jack's gelt to Charlotte's was 2 to 4. The ratio of Charlotte's to Ethan's was 6 to 5. The difference between Jack and Ethan was 8. So in this problem, it looks like we have a bunch of kids. We have Jack, we have Charlotte, and we have Ethan. So this sounds like we are going to be comparing 3 quantities. And in our questions from up above, we need to figure out who or what is the overlap, because this kid is going to have the same amount. And if we look at the ratios given to us, our overlap is Charlotte. So in the other video, I think we would have had it set up where it was like Jack to Charlotte to Ethan, and then we would stack it like this, just pulling information from the problem. So today we're going to be looking at another way that might be a little bit more clear, but is really similar to that. So we're going to set it up where first we know Jack to Charlotte was 2 to 4. And we know Charlotte to Ethan is 6 to 5. So in this, the way we have it set up right now, we know that these 4 units of Charlotte have to be the same value as those 6 units to Charlotte, because she's not going to have a different amount of gelt depending on who she's being compared to. So we need to find a common number for both 4 and 6, so that way we could convert both of these ratios into equivalent ratios that give us the same number. Now I could do 4 times 6 and get 24, but from chapter 1 I remember that least common multiple, that for this one it could actually be 12. And so I know if I ignore the Charlotte to Ethan right now, I could set this off to the side. Zoop. If I'm just looking at Jack to Charlotte, a 2 to 4 ratio, I can turn that into a something to 12 by multiplying by 3. So Jack to Charlotte, that's not 8. Wow. How about we do 6? So we know Jack to Charlotte is equivalent to a 6 to 12 ratio. Now when we pull Charlotte, Ethan back in, I know that a 6 to a 12 is times 2, so we can equivalent ratio this where that 5 is a 10. So now we have a 6 to 12 to 10 where Charlotte, her value is the overlap here, and now we can compare all of these kids evenly. And this is what we did over in this side over here, where we knew 12 was our least common multiple. 4 to get to 12 was times 3. 2 times 3 got us our 6. 6 times 2 is 12. 5 times 2 is 10. So it's very similar, but your work kind of overlaps in a way that might get a little bit more confusing. So if you like it, this way seems to be very clear and easy to catch if you've accidentally made a mistake. So looking at the bar model, for this one, we know we have Jack to Charlotte to Ethan. This is Jack, Charlotte, and Ethan. So Jack has, he started with 2 to 4. Oh man, my tummy is growly this morning. So we started with 2 to 4. Let me duplicate one more time. Okay, great. And then we converted that into a 6 to 12. So each one of those got chopped into 3 pieces. 1, 2, 3. 1, 2, 3. Okay, more of those. And now Charlotte has 12, Jack has 6, and we need to get Ethan's 10 in there. So I am just going to steal this, I think, and then adjust it from there. So I can do a little bit of erasing. So there's 9, 10. Okay. All right. So we do have another piece of information in this problem. So if you're looking at our breadcrumbs, the first thing we did was we identified what we knew. Whoa, I thought that was not going to be that. I was looking for this one. We identified what we knew here, who our overlap was, how we could use equivalent ratios, and then we're getting to our model. So first we did this, then we looked at our overlap, did some equivalent ratios. 4 is our model. So in the problem, they tell us that the difference between Jack and Ethan's gelt was 8 pieces. And so we see that the difference between Jack and Ethan is this bit right here, those extra pieces. And so that's 4 units. And according to this problem, those have a value of 8 pieces of gelt. So that must mean that 1 unit is 8 divided by 4, or 2. So each one of these units is 2. So our total number of gelt then is going to be, if we counted up all of those units, is 6 plus 12 plus 10, or 28. We need to just do 28 times 2, or 56. So once you have this information, then everything else is just filling in what do you know and then doing the calculations from there. So for part B, we know Jack, Charlotte, Ethan. I'm going to do these much quicker. This is 6. This is 12. And then 10 would be about there. 10. If the total is 168 pieces, we know that 28 units is 168. So 1 unit is, we just have to do some division here of 168 divided by 28. I don't know, 28 plus 28. So 28 once is that, twice is 56. 4 times is 112. So 6 times is 168. So I just did some adding into there. So 1 unit is 6 pieces. I'm sorry if you can hear people screaming outside the door. So we know that Jack has 6 times 6, Charlotte has 12 times 6, and Ethan has 10 times 6. So those would be our 2 main types of real-world problems, and those are kind of the updated ways we have of solving and looking at them. There are some extra practice. 25 and 26 from the review are really good ones, and then also the Check for Understanding from December 5th, which is 4.3 day 3, is a great place to look as well.